Okay, now we're crossing over to the realm of using Laplace transforms and their inverses to solve differential equations. And the introductory part, have presented in the top page of what we have in the Laplace transforms and operatives page. And just kind of a breakdown, if you have a function x of t, we have the Laplace transform is going to be equal to, and we'll just call this Laplace transform x of s. And then crossing over for the first order derivative of x of t, this Laplace transform is going to be equal to s times, the Laplace transform x of s minus x naught. You have for the second order derivative, you have equal to s squared times the Laplace transform x of s minus s times x naught minus x naught prime. And so you're going to have throughout, you're going to have one Laplace transform x variable throughout. And if you were to go up to the nth degree in the derivative, you have for the breakdown, you have algebraically have s to the same power as the order of the derivative, so you have s to the n times Laplace transform x of s minus, and you have s to the n minus 1 x naught minus s to the n minus 2 x prime naught, and going out to where we have in the constant we have x to the n minus 1 derivative order of 0, or at 0. Now, let's say that if you're looking at utilizing Laplace transforms, and we'll take as an example, say if we have a first order differential equation, and let's say that if you're looking at solving for x of t, and we have in the equation, so we have x prime, we have plus 4x, and we'll just start out with homogeneous equation, and we'll have with the initial condition, we have that x naught is equal to 5, and now just putting what we have in the terms and translating out what we have here. So you have x prime. Now putting in the lingo of the Laplace transform of x prime of t. If you notice, you have above, you have Laplace transform x prime of t. So you have is equal to s times the Laplace transform x of s. You have minus x naught. And notice we have x naught is equal to 5. So we have in following through, so you have s times Laplace transform x of s minus 5. And we have in the case of 4x, now again, so you have a multiple. So you have the Laplace transform, what's going to be 4 times x of t. And 4 is just a multiple. And again, for the Laplace transform of x of t, again, this goes to the Laplace transform x of s. So you have 4 times the Laplace transform x of s. Now, and we have also, we have with the constant 0, Laplace transform of 0 is equal to 0. So taking what we have in the equation, and we have upon replacing, so we have representing x prime, so we have s times x of s minus 5, and we have plus 4 times x of s is equal to 0. And so we have, upon combining what we have here, so we have, just bringing up what we have now, so we have s times x of s minus 5, and we have plus 4 times x of s is equal to 0. And just putting together what we have here. So I'm going to combine the Laplace transform x of s terms. And anything else, I'm going to move over to the other side. Okay, so we have with our Laplace transform x of s terms on the left, I can express in factored form. And so we're going to have, in this arrangement, so we have the quantity of s plus 4 times the Laplace transform x of s is equal to 5. And we have with x of s, that is going to be equal to 5 over s plus 4. And for what is going to occur is that for the solution that we have for x of t, okay, that is going to be equal to the inverse Laplace transform of 5 over s plus 4. And that is equal to 5 times the inverse Laplace transform of 1 over s plus 4. You can also write this as 1 over s minus negative 4. And we have for the result here, we have 5. And the inverse Laplace transform of 1 over s minus negative 4. This will be e to the negative 4t. Okay. And so we have for this final result, okay, we have the solution, in this case with the given initial condition and all, we have equal to 5 times e to the negative 4t. Okay, let's say we have for the second problem, make this almost exactly like what we have earlier, and the slightest change. Let's say we have x prime plus 4x is equal to 1. Then we'll have the same initial condition, again, where we have x naught is equal to 5. Okay. And so in looking at what we have in the setup, so you have the Laplace transform of x prime of t. And for what we have here, so again, we have s times Laplace transform of x of s minus x naught. And once again, we have s times the Laplace transform of x of s minus 5. And again, we have with the Laplace transform of 4 times x of t. We have equal to 4 times the Laplace transform of x of t. And this is equal to 4 times, once again, the Laplace transform x of s. Now, we have the equation not set equal to 0, but 1. Now, for the Laplace transform of 1, again, that is equal to 1 over s. So, in taking what we have now, and we have much of the history to repeat. Okay, so we have x prime, so we have s times x of s minus 5. And have plus 4 times the Laplace transform x of s. And we have equal to 1 over s. And now, I'm just going to kind of consolidate here. So we have the quantity of s plus 4 times x of s. And if I look at adding together, okay, so I have 1 over s plus 5 and think of 5 as being 5 times s over s. So I can go ahead and consolidate these terms together. And that is going to be equal to 5s plus 1 over s. And putting the expression in terms of the Laplace transform x of s, we have 5s plus 1 all over s times the quantity of s plus 4. Now, for what we have in the setup, and just kind of putting the expression what we have sort of at bay. Now, I'm going to go back to the beloved exercise of partial fraction decomposition. And we have a couple linear factors. So you can see we have a over s, and we have plus b all over s plus 4. And if we clear out the fractions, multiplying by both s and s plus 4, so you have 5s plus 1 equal to a times the quantity of s plus 4. We have plus b times s. And to solve for a, I can set s to 0. So b goes out. 5 times 0 plus 1 is 1. 0 plus 4 is 4, so I have 4a. So we had that a is equal to 1/4. And if I cancel out a, so I can set s to -4. And here, 5 times -4 is -20, plus 1 is -19. -4 plus 4 goes out. Then we have b times -4, so I have -4b. And if I divide by -4, okay, b comes out to 19/4. Okay, and so we have for the partial fraction decomposition, we have with a over s, so I can say that I have what's going to be 1/4 of 1 over s, and with b at 19/4, 19/4 of the reciprocal of s plus 4. Okay, and so looking at going back to what we have here, so we have with the Laplace transform x of s. Okay, so now we have, once again, so we have 1/4 of 1 over s plus 19/4 of the reciprocal of s plus 4. Okay. Now, for what we have in the case of x of t, okay, so taking the inverse Laplace transforms, so you have 1/4 of the inverse Laplace transform of 1 over s, and we have plus 19/4 of the inverse Laplace transform of the reciprocal of s plus 4. Okay, so again we have with the inverse Laplace transform of 1 over s, okay, that will go to 1. Inverse Laplace transform of the reciprocal of s plus 4, that is e to the -4t. And so we're going to have, at least for the final outcome, we have the x of t is equal to 1/4 plus 19/4 of e to the -4t.